I'm recording chapter 2 in English lesson for neural network control course. Chapter 2 titled The Learning Process. Of course, we are just summarizing different types of neural network learning methods, and additional information will be provided in future chapter. The first thing to know is what a signal flow graph is. This is called a signal flow graph, which is a curve, which is a circuit that consists of some nodes as the neurons and some branches and a transfer function as you see. There are some rules related to this signal flow graph that are stated here. There are two types of branches, as the linear branches are shown here, that the output is the summation of input times weights, and for non-linear weights, the output is depending with respect to the activation function. The output signal of a node is equals to the algebraic sum of all signals, as we have shown here. Yk is equals to yi plus yj. And the output signals from a node is transferred equally and independently to all branches connected to that node. What is a learning process? In general, learning refers to balancing weights, coefficient, and updating the weights through a learning process by adjusting the weights and biases. And learning is that the neural network is learning from the environment and improving through the learning process. These are the different learning process, as is called learning algorithm, depending on the rules, and learning paradigms. Learning algorithms are error correction learning, Boltzmann machine, Hebb learning, and competitive learning. With respect to this, we have different learning process as you can see. Supervised learning for error correction perceptron is used supervised learning, and some competitive learning are related to self-organized networks which are unsupervised learning. Here we have the target for supervised learning, and unsupervised learning we don't have the target. What is the error correction? Error correction learning or back propagation is respect with the error signal, which is the difference between the actual output and the which we have the ideal output, which is the desired output, and here we have the network output. And with respect to the error signals, we would of course use the const function as the least square error to update the weights. In order to update the weights, we have to find the new weights, where new weights are equal to old weights, the amount of weights at n, plus the changes of weights. Weight changes at moment n. With respect to that, adding the learning coefficient to this process in order to get a weights, adjusted weight, in order to adjust the weights, to find optimal weights. Here we are showing how to determine the value of learning coefficient, which is the learning coefficient is a very important factor, of course, in this learning process. How do you select this? This is, of course, a positive number, something between 0 to 1. How do you select it? Can you select this to be near to 0 or near to 1? This would be explained in future chapters. Now introduce Hebb learning. This is a Hebb learning. For competitive networks, there are two rules. They are stated here. You can go over these two rules for, of course, eliminating some weights and eliminating some neurons in the process, of course. And the hem learning mathematical model is showing here with respect to showing the changes in weight, which is the learning rate times the output and the input. There are some limitations for HEB learning. They are stated here, of course. And what is the competitive learning? Competitive learning, of course, are for networks that they're using unsupervised learning. We don't have the output. We don't have a desired output. We don't have a target to adjust the weights. In this respect, the network should adjust its own weights. So it is explained here what is a competitive learning. The learning process is summarized in this statement as the variable changes of the neurons to find the winning neuron, which one is the winning neuron, and where the not winning neuron are stated. So in this case, we have an initial state, and in the final state, after the training process, of course, the response of the network would be randomly distributed between the weights. Boltzmann learning is showing here for classification of pattern classification. Boltzmann learning is used, of course, as a random state reaching the thermal equivalent. As you can see, a Boltzmann network consists of some visible neurons and some hidden neurons, a layer of visible neurons and a layer of hidden neurons. And this is the process of learning with respect to this cost function as the energy, and with respect to the changes of states of the neurons. In this respect, we are trying to reach a temperature that it would be the optimal temperature, and the weights are, of course, adjusted randomly. And this is shown mathematically here with respect to the probability of changes of inner states, and using the learning rate, we will construct this equation for the learning process of Boltzmann machine as delta omega ji. This is showing you the supervised learning, of course. Supervised learning, as you can see, supervised learning is a learning process that a teacher or the desired output is controlling to adjust the weights, and in unsupervised learning, you can see the network should adjust its own weights, and we will, of course, in chapter 7 explain the reinforcement learning as well. Finally, different tasks are defined for the learning process in neural network. As you can see, neural network can be used for approximation. You can use RBF network, for example. Hopfield network is used for regeneration of the signals from noisy signals. It is called for signal processing. And we have pattern classification. We can use neural network for pattern classification, multi-layered perceptron, and we can use neural network for prediction, which is very important, that we can use a neural network for prediction. Past values of signals are given to the network, and we do expect the network to find the current or to find the future states of these signals. So this is very briefly reviewing chapter 2, and in detail it is explained from the book. I would submit the book for you, and you can use the hacking book and as a reference for chapter 2, which is very important to get just familiar with the different learning processes.